This time we will have our discussion about integrals that involves inverse trigonometric functions. We have here the basic formula to apply the integrals that involves the inverse trigonometric functions. We have the integral of du over the square root of a squared minus u squared, which is equivalent to arc sine of u over a plus c. Another formula, we have the integral of du over a squared plus u squared, which is equivalent to 1 over a arctan of u over a plus c. And also the integral of du over u plus the square root of u squared minus a squared, which is equivalent to 1 over a arcsecant of u over a plus c. Now, if we have here arcsine of u, this can be rewrite as arcsine of u. Okay, so we have our example for this particular formula. So we have here example number 1. This is how to apply this formula. We have the integral of dx over square root of 25 minus x squared. Okay, so let me erase this one. Okay, so if you have noticed this problem, this is similar to this formula. But then, if we apply this formula, we have to check our u. So, I will be applying du over square root of a squared minus u squared. So, of course, before I will use this one, I have to check my u. So, let u, for this case, our u equals x. And then du equals dx. If you have noticed this one, this is x squared, and then its u equals x, and its derivative, the derivative of u equals dx. Since this is also dx, then we can apply this formula. If for example, our du is, x dx, and then if you have noticed here, this is only dx, then we cannot apply this formula. Instead, we will find another formula. So, since our given here is dx only, and then we find our du as dx, then we will be using this formula. I will erase this one. So, by following this formula, we have our a, take note our a here is 5. A is equivalent to 5. So, since we use this formula, because we have our d equals dx, this is also dx, then we have here, I will highlight this one, dx. They are the same. Then we will apply directly this formula, which is equivalent to arcsine of u over a. Our u equals x, and then our a is equal to 5 plus c. So we use this formula. Next example, we have this one, 2dx all over is 7 square root of 7 minus 4x squared. Okay, again, this one is similar to this formula. Then we will check our u if we use this formula. So I will write our formula here, du over the square root of a squared minus u squared, and then it's u. For this case, our u equals 2x, because 2x times 2x equals 4x squared. And then our du is equivalent to 2 dx. Okay, if you have noticed this one, I will change this one to, let's say, 3. Okay, if you have noticed here, this is dx, this is also dx. The only difference is the number. Okay, we have here 2 dx and then this one, because 3, for this case, I will rewrite as here as the integral of dx over square root of 7 minus 4x squared. So if you have noticed here, this is dx, this is 2 dx. The only difference is this 2. And then this one is, of course, 1. So again, since our du satisfy this formula, this formula, so we can apply this one to our problem. However, if our du is equivalent to 2x dx, if you have noticed this one, this is dx, this is x dx, then we cannot apply this formula if in case our du equals 2x dx. Instead, we will be applying another formula. Okay, so for that case, since our du satisfied this formula, then of course, we will apply this formula. So, that is now equivalent to, we have here 3, and of course, this one is supposed to be arcsine u over a. So, we will copy that one, arcsine of u. By the way, we have here 2, so I will write sorry for that. Okay. Okay, I will write here, because this is dx, this is 2 dx, so I have to write 2. So we have here 3 integral of, instead of, okay, I will write here dx over square root of, now by the way, our a here is square root of 7 squared. That will be our a. So let me check this one, rewrite. Okay, square root of 7 squared, because square root of 7 squared is equal to 7, minus, we have here 2x, like this one, 2x, 2x times 2x equals 4x squared. In other words, you have to take a square root of 4, that is equivalent to 2. Square root of 7, we have here square root of 7 and then squared. Okay, now, we rewrite this one. Okay, now since our du is 2 dx, then we will write here 2 dx, and then we will write the reciprocal of 2. This is use substitution. So if we multiply 1 half times 2, that is equivalent to 1. In other words, we are just rewriting this problem, so that this one is equivalent to, okay, 3 over 2, and then this is supposed to be our du over this one equals the square root of a squared minus u squared. So we have this formula, so that our final answer equals 3 over 2, and then this one is equivalent to arcsine of u over a. Our u equals 2x, and then our a is equivalent to square root of 7 plus c. So that will be our final answer. Now we will have another formula, example number 3. So we have example number 3. I will write it here. Okay, I will transfer this one. So for example number 3, we have, okay, so the integral of arctan of x squared dx all over 1 plus x squared. Okay, so this time you have to select what will be your u, what will be your du. But of course, you have to select first a formula for this one. Now, if you have noticed here, uh, if you apply this one, 1 plus x squared, you have to check your du. Okay. So if we use du over a squared plus u squared, then we have to check our u. For this case, our u, if we apply this formula, our u equals uh, x, so that du equals dx. If you have noticed here, this is dx. However, once you declare this one as a squared plus u squared, these two functions, the remaining functions must be your target du. Okay, I will write it here. Arctan squared dx over 1 plus x squared. If we declare this one as our a squared u squared, then our target du must be this one. This is du, and then supposed to be du. However, this one, our du is dx. This is only dx. So this is only dx, and then this one, if you have noticed, arctan of x square root of, arctan of x raised to 2. Therefore, since our du is not, here, our du is dx, is not satisfied by this given problem, then we will not use this formula. Okay, so we will not use that formula. So I will write it, I will erase this one because we are not allowed to use that formula. Instead, we will be using another formula. So from our previous discussion, we have the basic integral. Applicable for this one is, let's say, the integral of u to the n du, which is equivalent to u n plus 1 over n plus 1 plus c. So this time, if we use this formula, then we will rewrite this one based on this format. So we have arctan of x squared, and then dx over 1 plus x squared. So this time, our target du will be this dx over 1 plus x squared. This one. Okay. u to the n, and then du. So this must be our target du. So this time we will check our u. Our u, if this is the case, then our u equals of arctan of x, and then the derivative of arctan of x, that is 1 over 1 plus x squared times the derivative of x, which is then equivalent to this one, dx times 1 over 1 plus x squared. So this is now dx. Therefore, since our du is similar to this one, then we can make use of u to the n du. So we will proceed. Our answer now equals u to the n du, which is equivalent to un plus 1 over n plus 1 plus c. So this time, we have here arctan of x raised to n plus 1, that is 3 over 3 plus c. So that will be our final answer. Next example, we have number 4. The integral of x squared over 2 plus x squared dx. So notice this one. If you observe, this is similar to du over a squared plus u squared. Again, if we use directly this formula, take note, if we use directly that formula, du over a squared plus u squared. Then we have to check our u. Our u for this one is, take note of this one. I will write it here. Integral of x squared dx over 2 plus x squared. This is 2 plus x squared. This is a squared plus u squared. So our target du is supposed to be this one. If we use directly this formula, x squared dx. So we will check our our u. Our u is x. And then our du equals dx. However, for this one, this is x squared dx. This is dx. Therefore, we cannot apply directly this formula. Instead, we will find another way, or we will make use of other formula. So this time, we will find another way. If you have noticed here, the exponent of your numerator, which is x squared, 2, so x squared. And then if you have your denominator 2 plus x squared, your exponent here is 2. So they are the same. Then all you have to do is to divide this one. But of course, before you divide, we will write it in this manner. We have x squared divided by x squared plus 2 dx. So if we divide this x squared, we have here x squared divided by x squared plus 2, then x squared divided by x squared, that is 1. 1 times x squared, that is x squared. 1 times 2, that is 2. And then we subtract this one. X squared minus x squared equals 0, and then negative times positive, that is negative 2. Therefore, when we write this one, when we divide, after we divide, then that is equivalent to the integral of 1 minus this negative 2. So minus 2 over this denominator. So I will write it as 2 plus x squared. Take note, x squared plus 2 is equivalent to 2 plus x squared. They are the same. And then we have here our dx. And then distribute dx. We have the integral of dx minus this one 2. I will write first 2 and then integral of dx over 2 plus x squared. So for this one, of course, the integral of dx equals x. And then this one is, now we can make use of du over a squared plus u squared. Our u here is x. The derivative of x equals dx. Therefore, we can use this formula. Our a here is the square root of 2. Take note, 2 is equivalent to square root of 2 squared, because this is a squared. So, supposed to be a square. So, integral of dx equals x minus 2. And then this time, this dx over 2 plus x squared is equivalent to 1 over a. So, 1 over a, our a is square root of 2. And then, arctan, I will make use of this one, of u over a. So, our u equals x. And then, our a equals square root of 2 plus c. So, that will be our final answer for that particular problem, number 4. So, I will erase this one. Next example is number 5. For number 5, we have here dx over x is square root of x to the 4th minus 16. If you have noticed here, this is similar to formula number 3. Du over the square root of u squared minus a squared, and then you have your u, which is equivalent to 1 over a's arcsecond of u over a plus c. Now, for this case, of course, we will identify our a squared and then u squared. Rewriting this one, you have dx over x is square root of x squared square minus 4 square. So if you look at this one, this is u, and then u squared, supposed to be x squared, square, minus 4. So in this case, if we use this formula, then our u, okay, let our u is equivalent to x squared, and then du is equivalent to 2x dx. However, this one is x dx. I mean, you have here your x. So if we write this one, since we have here x as our denominator, so actually we can rewrite this one as, okay. If we apply this 2x dx, you will have here 2x dx divided by, instead of writing x, we will make use of x squared. If you notice here, this is, if you divide here x and then x squared, then the remaining value here is dx over x, which is square root of this one. Okay, so we have here a square root of x squared square minus 4 squared. If you observe this one, since I have here 2, then I will write here 1/2. If you observe this one, this is supposed to be 1/2, and then this is, okay, I will write it here, 2x dx over x squared is square root of x to the fourth minus 16. Notice this one, you have here u x squared x to the fourth, u squared. Okay, anyway, we have here to write this one in this form, you have 2x dx, that is our du. Okay, divided by, this one is x squared, take note, u squared, x squared x to the fourth. Okay, and then this one is 4 squared. So we have du over u, which is our u equals x squared. Okay, this one, u squared, I mean u equals x squared. So this is x squared. So we have here u, and then the square root of u, this is x squared, this is x squared. So this x squared is equal to u. So u squared minus, this is 4 squared. So supposed to be a squared. If you look at here, du over a squared plus u squared. Therefore, that is equivalent to 1/2. And then instead of writing du over u is square root of a squared minus u squared, we have here 1 over a. 1 over a, our a here is 4 arcsecond of u over a. Our u equals x squared over 4, our a, plus c. So 1/2, 1/4 equals 1/8 arcsecond. I will write here arcsecond of x squared over 4 plus c. That will be our final answer for example number 5. This time we will proceed with example number 6. So we have the integral of dx over the square root of, let's say, 4 minus 6x minus 9x squared. Okay. If you look at this one, this is similar to arc sine integrals that involves in arc sine. So we have here dx over the square root of 4 minus 6x minus 9x squared. So we will rewrite this one. rearranging this one if we will follow this formula. So we have dx over the square root of 4 minus, open parenthesis, we have here 6x plus 9x squared. If we multiply negative times 6x, that is negative 6x, and then negative times positive 9x squared, that is negative 9x squared. And then if you have noticed here, this 9x squared plus 6x is a perfect square. This leads to a perfect square. So all we have to do is to add a certain value here. Okay, so we will form a perfect square for these particular functions. So if you have noticed, that is 9x squared. Square root of 9x squared equals 3x. So I will write here 3x plus, of course, a certain number, and then we will complete it. I mean, square it. So going back to this one, we will add a value here so that this will equate to 9x squared plus 6x. So we have 3x times 3x. When we expand this one, we have 3x times 3x, that is 9x squared. We have this one. And then 2 times 3x, that is 6x. So we will multiply by another number that will equate to 6x. So for this case, 2 times 3x, that is 6x times 1, supposed to be 1. So again, 2 times 3x equals 6x times 1, that is 6x. Which means this one is 6x, then they are equal. And then 1 times 1 equals 1. Okay, 1. So this is how we square this binomial, which is equivalent to 9x squared plus 6x plus 1. However, from our problem, we have here 9x squared plus 6x. There's no plus 1 here. Therefore, we have to subtract by 1. If we add 1, then we will subtract here by 1. So that 1 minus 1 equals 0. So what remains here is 9x squared plus 6x. Okay, so in other words, we just write 9x squared plus 6x in another way, because this one, if we combine this one, that is 3x plus 1 raised to 2 minus 1. Of course, this one is negative 1. Okay, so this time we have now created a perfect square, 3x plus 1. So by using this value, we have the integral of dx over square root of 4 minus, instead of writing 6x plus 9x squared, we will write 3x plus 1 squared minus 1. Okay, so take note, this one is equal to 6x plus 9x squared. These are equal. Take note, if we expand this one, this is the equivalent, and then minus 1. So if we have 1 minus 1, what remains here is 9x squared plus 6x. So in other words, this 6x plus 9x squared is equal to this one. So we write here we write this 6x plus 9x squared in another form. Okay, so I will delete this one so that I have an extra space. Now, next, we have the integral of dx over. So, by the way, my YouTube channel, we have here TDs apostrophe S TDs TV. Okay, so TDs TV. Now, we have, so don't forget to subscribe my YouTube channel so that you will know you will be notified with my other video. Okay, we have dx over the square root of 4 minus this one. So we will now multiply this negative sign. We will distribute the negative sign. That is dx square root of, we have 4 minus Okay, 3x plus 1 squared. This is squared, and then negative times negative, positive 1. So that this 4 plus 1 is equivalent to 5. Integral of square root, dx over the square root of 4 plus 1 equals 5 minus 3x plus 1 raised to 2. If you have noticed here, this is du, our target is dx, and then square root of a squared minus u squared is square root of 5, 5 squared minus this 1. So, we will rewrite this one in this format. Take note, I will rewrite du over square root of a squared minus u squared. So, for this one, we will write it as the integral of dx over square root of, instead of writing 5, I will write here 5 squared minus this one, 3x plus 1 squared. 3x plus 1 squared. Now, if we use this formula again, we have to check our u. Our u for this case is 3x plus 1. Its derivative, so du equals the derivative of 3x plus 1 equals 3 dx. This one is dx. This one is 3 dx. Therefore, we can make use of this formula. Okay. So, rewriting again, okay, dx over the square root of 5 squared minus 3x plus 1 squared. Okay, when we apply du, that is 3 dx, so I will write here 3, and then I will write its reciprocal, 1 over 3. So that this time, this is now equivalent to 1/3 3 dx, that is our du, integral of square root of this 5 squared, that is our a squared, minus this 3x plus 1 is our u is 3x plus 1, so u squared. Therefore, our final answer is 1/3. Then du is our du we have here. So we will apply now this formula, arc sine of u over a. So arc sine of u over a, our u equals 3x plus 1 over a, which is equivalent to, our a here is, this is supposed to be square root of 5. Sorry, this one is supposed to be square root of 5 because that is 5. So, square root of 5 square. So, square root of 5 plus c. This is now our final answer.